In this podcast, we're going to go through all of your sample heat calculations. So we're going to go through your MCAT equation, your heat of fusion, and your heat of vaporization. And then we're also going to show some sample problems where you have to use more than one equation to calculate the total energy you have in, say, a phase change. Just to refresh on the equations that we're going to be using, our heat equation is Q is equal to mc delta T, where Q is your energy, and we can measure this in calories or we can measure this in joules. M is your mass of your substance, C is your specific heat, and delta T is going to be your change in temperature. So our C value, we're going to be using a specific heat for liquid water. And I know that you won't always see this, but for this class, we're just going to use specific heat for liquid water, which is 1.00. And the units are calories per gram degree Celsius. So we'll be using that to cancel all of our other units so that we're left in the correct units for whatever it is we're trying to solve. Heat of fusion, you can calculate. You'll get a Q value. So again, that's energy, and that's equal to mass times your heat of fusion. In the podcast, we discussed the two different values that we can use for this. We are going to use 80 with a decimal point calories per gram. Your textbook uses 79.7 calories per gram, so beware of that on your homework, but we prefer to use 80 and be in line with your lab manual. Heat of vaporization is your energy will be your mass times your heat of vaporization, and that value is 507.40 with a decimal calorie per gram. All right, so our first sample problem asks us to calculate the calories. So this is what we're trying to find, released when 10 grams, that looks like a mass to me, of liquid water is heated from 10 degrees Celsius to 23 degrees Celsius. So this looks like my delta T right here. All right, so because I have two temperatures, I know that I'm going to have a change in temperature, and this is going to be an MCAT equation. So I'm going to write my equation, Q equals mc delta T. And I'm going to make sure that I'm identifying all my variables in the question. So calories is what I'm trying to find. This is my Q value in this problem. I have the mass identified, and I know my delta T is going to be the difference between 23 degrees Celsius and 10 degrees Celsius. My delta T is 13 degrees Celsius. Okay, so the only thing I'm missing is my specific heat, but that is a known value. This is liquid water, so it's going to be 1.00. So let's go ahead and fill in our numbers for this. We are solving for Q, so the equation's already set up the way we need it to be. So mass is 10 with a decimal grams times my specific heat, 1.00, and that's calories per gram degree Celsius, times my delta T, which is 13 degrees Celsius. Looking at my units, grams will cancel, degrees Celsius will cancel, leaving me with calories. And calories make sense. I can do my energy in calories or grams, depending on what the problem gives me. So I've set this up correctly for my units to cancel. Plugging these into our calculator and rounding to 2 sig figs, because that's the least in the problem, I get 130 calories with no decimal places. All right, our next sample problem asks us to calculate the heat needed to freeze 35 grams of water at 0 degrees Celsius. Okay, they want us to calculate heat, so that is going to be a Q value, and they give me this key vocabulary word. Anytime you see the word freeze or you see the word melt, we know that we're dealing with a heat of fusion calculation. That's really important for us to identify right away because that tells us what equation that we're going to use. 35 grams is going to be a mass. Now, they did give me a temperature. However, this is kind of tricky because they didn't give me a second temperature. So there's no delta T here. There's no change in the temperature value. So I can consider this extraneous information. It's extra stuff that I just don't need. So because I saw the word freeze, I'm going to set up a heat of fusion problem. So Q equals MHF. I've identified my mass as being 35 grams. I'm going to go ahead and plug in 35 grams. And I know that my heat of fusion is a given value, and that is going to be 80 with a decimal calories per gram. So I'm going to go ahead and plug that number in here. grams are going to cancel, leaving me with calories, and that's a unit that makes sense for what I'm solving for because Q values can be in calories or joules. So 35 times 80, and then rounded to 2 sig figs is going to give me 2,800 calories. Our next sample problem asks us to calculate the heat change at 100 degrees Celsius, which is a temperature, when 10 grams of steam, that's a mass, is condensed to water. There's my keyword condensed. Anytime you see the word vaporize or condense, we know that it's going to be a heat of vaporization equation. So Q, or my energy, is going to be equal to the mass times the heat of vaporization. I know my heat of vaporization is 540 with a decimal calories per gram. So now it's just a matter of plugging in some numbers and doing some calculations. They've asked me to calculate the heat change. They want to know how much energy I have either added or gained. So Q is equal to 10 with a decimal grams times my heat of vaporization value, which is 540 calories per gram. Grams are going to cancel, leaving me with a unit of calories, which makes sense because I'm solving for Q. So what you get rounded to 2 sig figs, because there's 2 in my original mass and 3 in my heat of vaporization, is I get 5,400 calories. In our last sample problem, we're going to kind of put together some more ideas and do a little more complex multi-step problem. So they ask us how many calories, that sounds like a Q value to me, are required to condense. Ooh, this is good. We have a keyword here, condense, so that tells me right away for sure I'm going to have a heat of vaporization problem. 125 grams, this is my mass, of steam at 100 degrees Celsius, and then to cool the liquid to 15 degrees Celsius. We have a change in temperature. We finally have 2 different temperatures. Anytime you have a delta T, that tells me that I am going to have an MCAT equation. So Q equals MC delta T. So I'm actually going to do 2 different equations and get 2 different values for my calories, and I'm going to add those together. So in this problem, I have a state change, which is represented by my heat of vaporization, and I also have a temperature change, which will be my MCAT. All right, so let's go ahead and do our heat of vaporization first. So Q is equal to the mass, 125 grams, times my heat of vaporization value, which is 540 calories per gram. Grams will cancel, leaving me in calories. And from this, you are going to get 67,500 calories. Okay, so I'm going to set that value aside. I double checked it has 3 sig figs, which is what both the values in my problem have. And now I'm going to switch over and do my MCAT equation and deal with the change in temperature. So Q is equal to, same mass, 125 grams times the specific heat, and we're just going to use a specific heat of liquid water for our purposes in this class. You may see a different value being given if you take a higher chemistry than our Intro to Chem class. And my delta T is going to be the difference between 100 and 15 degrees, which is 85 degrees Celsius for my delta T. And we're going to go ahead and cancel some units. So grams will cancel, and degrees Celsius is going to cancel, and that's going to leave me with a value in calories. That makes sense. I'm solving for Q. All right, so when you multiply these guys together, you get a value of 11,000. And I had to round this to 2 sig figs because my temperature and my original temperature had a value in 2 sig figs. So I have 11,000. So now I have these 2 different values that I'm going to have to add together to get my total energy through this. So I have 67,000 plus 67,500 plus 11,000. Because we are now switching rules, we are not doing our multiplication addition rule and going with the least number of sig figs, we're going with the least number of decimal places. It doesn't matter that I'm going to increase my number of sig figs here. So adding these 2 together, I get 78,500 calories. Make sure, because neither of these have decimals, that your answer doesn't have decimal places.